Now that we have seen a lot on the machine side, in combination with the tools and the control, let's take a look at clamping devices. We got mechanical clamping devices, we got pneumatic, and we also have the vacuum table. The vacuum table is actually perfect for whole plate materials, even larger plates. But what is the secret behind it? Actually, we have a vacuum pump somewhere beside the machine. So a hose goes into the machine and distributes the vacuum through the table. So we have, in this case on an ML Cube, 6 connections that go through the polymer concrete table. So the vacuum would float into this vacuum fixture, vacuum plate. It's like a sandwich plate, so it's like internal distribution. And then we have these 100 by 100 millimeter fields, the meander slots. So it's like a pattern, like a slot that goes from here to there, and we have this little rubber plug in the middle. So with a little key, we can basically activate or deactivate those fields because they have like an eccentric hole. So they would either let the vacuum through or seal this section. So what I'm doing is I'm taking my piece of material, check the size. So I would approximately open the same size as my material is. This would be like roughly 200 by 200. So I've opened 4 of these plugs. Now before I put the plate on the table, the vacuum card goes in between. The vacuum card is a sacrificial layer which has a thickness of 0.7 millimeters, and that goes in between the table and the part. It means that we can cut through the material into this paper without harming the vacuum plate, and we don't lose a lot of vacuum when we cut through. Because imagine if you have like a lot of pockets, you open up a part on a standard fixture with a gasket, you would just lose a lot of vacuum. I activate my pump now. And this part is now rock solid on the table. I take my single fluid end mill now, and we just take like a little, or cut a little disc out of this. We see if it holds on the table, and then I'm gonna explain a little bit more about this technology. All right, now that we have cut through this part, let's just see how it holds on the table. So I'm not able to move this from the table, but I can feel with the palm of my hand the effect of the vacuum. If I switch the pump off now, I can just easily take this off. So we can see we have a sharp edge but no burr on the part. And if we take a close look at the vacuum card, we can see that we have basically the shape, the contour that we milled through in the paper now. We usually go about 0.2 to 0.4 millimeters deeper into the vacuum card. That just to make sure that the part is completely cut out and that we get a nice and sharp edge. And because of the remaining cardboard here, the vacuum power and the force itself holds on or stays still quite high. So vacuum is actually the perfect work holding solution when it comes to plate materials. You can also batch parts, just put a large piece of material on the table and just cut multiple parts out just by pressing the start button once. Alright, besides the vacuum clamping technology, we also have mechanical elements in order to hold our parts. We got the pneumatic one, which we're gonna take a look later on. I first want to mention the centric vise. Is basically a standard vise with soft jaws in this case. So aluminum soft jaws can be You can mill any contour, any shape of your part that you need, or if you just need basically a parallel step for any part. Also possible to get the vise in a longer version and with wider soft jaws. So these aluminum soft jaws can be just mounted on the vise itself. Let's talk about the pneumatic clamps, the short stroke elements. I mentioned it at the beginning of this video. We have a T-slot plate, a fixed jaw in the back, and we got those short stroke elements. They have a vertical cylinder, which is located here in the center, and a horizontal one for the short stroke. If I press this bolt down here, I can drag it out, and you see there is this little T-stone, and if I release it, the T-stone will be basically pulled upwards. So if I move this into a T-slot, stone into it, and release it, it's fixed on the plate. So whenever I want to hold a part and clamp a part, I take this part. I got a little step here with a dovetail cut in it. I move my part, my short stroke element, the flexible element, to the edge of the part. So I can just move it in the X direction in this case, and all I got to do now is pushing the upper bolt, which gives the clamping force in the horizontal direction towards the fixed jaw, and now this part is locked. These elements are pretty flexible. You can combine multiple elements, also multiple T-slot plates in different lengths, and like round parts can be held. You can orient them in different orientations. So let's just say you have a big round part where you want to clamp over like 3 points. That would be possible, or you can use those as soft jaws. We saw this M8 Cube with the cutout table right at the beginning, and we have the vertical clamping device mounted vertically on it. What can I do with it is I can use it for applying like threads or breakouts in very like high parts. It's not possible to mount this on a table like this because the clearance of the gantry would just not allow it. So I can simply place it down to this vertical end stop that's adjustable. Put it basically to the side or any other mechanical stop. I can move those elements. Those are pneumatic elements, just similar to the ones that we saw with the short stroke elements. Then I move this bar over so it has different lock positions. And then I just release this short stroke. So I give pressure on the part against the T-slot plate. And now my part is properly held, and I can easily make those threads or cut out in the table. Of course, the force, the clamping force, is not as high as like on a vise or on a like really tight mechanical device. But mostly for just making breakouts into like housings or plates or covers, it's absolutely sufficient and an extremely flexible solution, as you can do stops or clamps just as you need them. They could be mechanical with like T-stones or just simply using screws to mount parts. Another great option when it comes to avoid dust or chips in the machining area is the clean cut system. It's highly recommended to use it when it comes to abrasive materials like carbon fiber or glass fiber, where you have this like aggressive dust which can harm the mechanics of the machine, like the ball screw, or even affect the lung of the operator, because this very fine dust goes into your lung when you breathe in. That's why we have the clean cut. It's basically mounted on the Z-axis, and it has this head which moves a little bit downwards and under the spindle and under the tool, and the pipe and the hose goes from the tool all the way out to the machine into an industrial vacuumer. So the chips or the dust will be collected outside in a tray or whatever system. I will now just move the head down and just explain a little bit more how it works. Close the door. So when we now take a look at the system, it's a static system, so before I start my work, I check the thickness of my plate, and I can move this up and down with this knob on the side here, with the yellow cap. So I can adjust the height a little bit. So whenever it comes to plate materials and like plastic or abrasive material cutting, this is an extremely helpful software. The deeper you go, the less suction power the system has, because there is just the airflow is getting less, or the power which pulls on the chip is getting less the deeper you go. So if you have like big pockets of, let's say, 20 millimeters, the efficiency will go down. But if you have thin materials, absolutely a great add-on for the machines. And let's take a look how it works when we cut the pocket into this plate. The DATRON Axis 4 is the perfect add-on for any of the machines from DATRON Neo up to the MX Cube to make a 4-axis machine out of this 3-axis gantry system. It comes with optionally different clamping systems. We have a 3-jaw vise for round stock material now in the machine with a tailstock. You can also use a centric clamp just to get like straight parts like plate material in. The machine can both perform simultaneous movements as well as indexing. So simultaneous is what we currently see. All axes are interpolating at the same time, inclusive the A-axis, the rotation axis. Indexing would just be going into one angle, then making a feature in 3 axes, repositioning with the rotation axis. I just stopped this program quickly so we can get a closer look. It can be taken off from the machine in case you don't need it. So it's just like any other clamping system. It's just bolted down on the table. And as you can see in this setup, we even have half the table with vacuum equipped. So that is actually a perfect solution to expand the capabilities of the machine. And on a lot of parts, even where you would think that it is a 3-axis part, and you just have to clamp it a couple of times in a vise, should be worth to consider to do it on the 4th, where you can just do multiple angles, multiple sides at a time, top and bottom, and then just facing off the rest material. Definitely a great add-on for all the machines.